Analyzing polynomial function. During a diagnostic evaluation, a 33-year-old woman experienced a panic attack a few minutes after she had been asked to relax her whole body. The graph shows the rapid increase in heart rate during the panic attack. Heart rate before and during a panic attack. So the y-axis represents the heart rate, beats per minute, while the x-axis represents the time in minutes. So here we have a sum question. Let's try to answer this question. For which time period during the diagnostic evaluation was the woman's heart rate increasing? The heart rate is increasing, if we are looking at the graph here, is from 1 minute, let me take one pen, from 1 minute to 4 minutes. So here was increasing. The function was increasing in this interval. So increasing was from 1 to 4. So let me write here, 1 to 4 is increasing. 1 to 4. So it was increasing. And then the other interval was between 8 minutes to 10 minutes was increasing. From 8 to 10. So in the graph from 8 to 10, it was increasing. And now we are looking here is increasing. And now we are looking for which time period during the diagnostic evaluation was the woman's heart rate decreasing. Decreasing here is from 4 to 8 minutes. And the other interval is from 10 to 12 minutes. So it means from 4 to 8. To 8 was decreasing. Let me write decreasing here. And the other interval was from 10 to 12. From 10 to 12. So it was decreasing. So it was decreasing here. And then we have a C. How many turning points from increasing to decreasing or from decreasing to increasing occurred for the woman's heart rate during the first 12 minutes of the diagnostic evaluation? The turning point is from increasing, decreasing. Here is 1. And the other is decreasing, increasing. This is 2. And the other one increasing, decreasing. This is the 3. It means there are 3 turning points. So 3 turning points. And suppose that polynomial function used to model the data displayed by the graph using time during the evaluation heart rate. Use the number of turning points to determine the degree of the polynomial function of best fit. So we already know the turning points can be evaluated or can be calculated by the formula 1 minus n is degree. So whatever degree is 1 degree is less, that is the most turning points. And this function here has 3. It means it can be 3 minus 1. 3 minus here is equal with what degree is going to be. And if we have here now, we are going 3 minus 1 is 3 we have, right? Turning points. And now we want now to calculate this turning point. I am adding plus 1 both sides. So if we are adding both sides plus 1, then it means the degree n is going to be equal to the 4. It means the function is going to be the 4th degree. And in E says, for the model in part D, should the leading coefficient of the polynomial function be positive or negative? But as we see here, endpoints of this function, on the left is falling and right is falling. It means that the leading coefficient should be negative. So the leading coefficient can be negative. So the leading coefficient is negative because the end behaviors of the function are falling on the left side and the right side. And obviously this is an even degree. It's already we can find out according to the test of the graph of the function or end behaviors for the polynomials. So the leading coefficient is negative. And F says, use the graph to estimate the woman's maximum heart rate during the first 12 minutes of the diagnostic evaluation. After how many minutes did this occur? The maximum point we see is here, but between 110 and 120. But it looks is a little greater than 120. So the maximum can occur. The maximum can occur in let's say it looks a little bit higher than 115. So it's 116. We can say for plus minus 1, maybe we can be wrong, but for plus minus 1 is there somewhere, is around 116. So this is the maximum, and it happens in the 10 minutes. When it was 10 minutes, during the 10 minutes period. This can happen. This is a F. And G is the last one. Use the graph to estimate the woman's minimum heart rate during the 12 minutes of the diagnostic evaluation. After how many minutes did this occur? If we are looking for the minimum is here and at this point here. But it's at the point where is a second turning point, it looks is a little bit lower than between 65, between 60 and 70. So it looks like it's less than 65. But this one here looks is at 1 minute, in the first minute, it looks is a little bit higher than 65. So I would say is a 64 somewhere, plus minus 1, and it's happening during the 8 minutes. So that's what is happening. The minimum heart rate during the 12 minutes.